Hi folks, we're going to take a look at 4b from part A of the Unit 3 assignment. So they give us this function and they want us to find the critical points, determine whether any of them are local extrema, and are the tangents at those points parallel to the x-axis. In other words, are they horizontal or is the derivative equal to 0? So let's start by finding the derivative here. So g prime at t is equal to, so here I'll have to use the quotient rule. So let's start with the derivative of the numerator. So again, that's going to need the chain rule. So e to the u is just equal to e to the u in terms of the derivative. So e to the negative 2t. And then, of course, I have to take the derivative of negative 2t, which is just negative 2. Okay. Then times the denominator function minus the numerator function times the derivative of the denominator function, which is just 2t, all over the square of the denominator function, so t to the 4. Okay, now again, we've seen that what's really useful in simplifying expressions like this is going to be common factoring. Okay, and we definitely want to simplify, since we have to solve an equation with this derivative. Okay, so here what do we have? Well, they both have an e to the minus 2t. They both have a 2. They both have a t. Okay, in fact, I think I'm going to take out a negative 2 because I notice there's a negative in both. So we've got negative 2, we've got a t, and we've got an e to the minus 2t. Okay, and let's see what we have left. So here, looks like we've taken out everything except one of the factors of t. Okay, and here, well, we've taken basically everything out, including the negative. So I'm just going to have plus 1 all over t to the 4. Okay, and in fact, I can do a little more reducing, reduce this t in the numerator, and this in the denominator will just become cube. Okay, so this is much easier to handle. Now, in terms of critical points, if I look at where the derivative doesn't exist, it's at 0, but that's not going to be a critical point because at 0, the original function doesn't even exist. So I'm only looking for when the derivative is equal to 0. Okay, this is pretty easy to solve since e to the minus 2t can never be equal to 0. So the only thing is this one here. So t can be equal to negative 1. Okay, now since they're asking for the critical point, I'll take g at negative 1 to find the y value. So that's just e to the negative 2 times negative 1 all over negative 1 squared. So what do we have? We've got e squared over 1, so just e squared. Okay? So my critical point is negative 1 e squared. All right. So now let's determine if it's a local extremum or not. So I'm going to do my number line for g prime. Okay. Now, while I'm only interested in negative 1, I'm also going to include the 0, the other critical number. Okay, because I need to make sure, because remember here the derivative can change sign from across 0. So I need to make sure that when I'm testing my sign to the left and right, I don't pick a number past 0 when I'm trying to determine if that's a local extremum. So remember, even if something's not a critical point, but it's a critical number, you always include it on your derivative, or even similarly with the second derivative on your number line. Okay, so let's pick so let's pick negative 2 here on this side. So I know that I've got this negative out in front. Okay, here this is always positive, so I don't have to worry about that. And then negative 2 plus 1 is still negative. Okay, all over. So negative 2 cubed is still negative. Okay, so in the end, we've got positive in the numerator, negative in the denominator. So it's negative on this side. Okay, and let's pick, say, something like negative 0.5. Okay, we still have this negative out front. Okay, this now becomes positive because negative 0.5 plus 1 is a positive number, and the denominator, negative 0.5 cubed, is still going to be negative. Okay, so now this is just going to be positive. So because of this, because we're switching from negative to positive, in other words, from decreasing to increasing, we have a local min at our critical point of negative 1 e squared. Okay, and in this case here, the tangent is parallel to the x-axis. Okay, and we know that because that made the first derivative equal to 0. Okay, so just a quick recap here. Find the derivative. Make sure you simplify all the way by using common factoring. From there, easily determine your critical points, test your signs, and determine whether you've got your local extremum there or not. Okay, that's it for this one.